Hello, welcome to another video for the series Through the Eyes of an Engineer. We're going to talk about programming languages, a subjective perspective. This is only through my eyes, subjective look at programming languages and what I think about them through my relatively short experience with software, which is about 18 to 20 years. So why so many? We have so many programming languages, and I can guarantee to you that the list will keep increasing. There is A, B, but they're dead. C, C++, D, Java, etc. And the list goes on and on. Some are compiled, some run on virtual machines, some are functional, some are object-oriented, some are both. It's a mess in my opinion. So why so many? For each language, we have paradigms. Is it object-oriented? Is it functional? Pure functional? Etc. Each language has libraries, frameworks. There's compiler or interpreter tricks that you need to be aware of. There is IDE setup that has to go along with it. The language has versions, C++, C++, 11, 17, Java this version, that version, enterprise editions, etc. For each paradigm, there are patterns. And right now, unfortunately, people take patterns as if there's something that's engraved in the stone, although the author of the book, Modern C++ Design, for example, he tells you that you should adapt your thinking to your problem. But they lock themselves to these strict patterns, and you have to learn these patterns, and you end up with 10 classes sometimes to do small problems. I've seen that all the time. There are best practices that you have to know to avoid pitfalls. There are libraries and frameworks, and for each one there are manual pages, documentations, hidden bugs, undefined behavior, undocumented behavior. For each IDE, you have a setup, you have a learning curve. Is it Emacs? Is it Eclipse? Eclipse seems simple, but then you go into plugins and you screw up your setup, you go edit the XML file. It's a disaster sometimes. For each compiler, WTF moments. I don't need to go further on that. Now here's the thing, all useful languages are Turing complete. The true language of the processor is assembly language or opcodes. Is it opcode? I think it's called that. Anyway, basically it's a number which represents the instruction and what follows it, if I shall call it parameter, so to speak. And you can literally translate that into binary by hand if you have the manual for the processor. You can do that easily for small controllers like PIC controller. It will take you a bit longer for Intel chips or AMD or ARM because the instruction set is a bit bigger. But you can imagine that your assembly language is a set of instructions and your code is a tape that uses these instructions, and then you have a Turing machine. And the languages are Turing complete, meaning they can solve a same subset of classes no matter how hard it is. Now, what's the proof that you can solve same problem? Well, if you can write a Lisp interpreter in the language of your choice, and we know that a Lisp, or let's call it Common Lisp in that case, and that Common Lisp is a Turing complete machine. Why do I choose Lisp style language? Because it's easy. That whole thing is a whole discussion by itself. Anyway, but you can do that, and then you have a Turing complete machine. It's the same problem solved over and over. It's just people think differently and they want to express ideas differently. Why so many? Languages are not orthogonal. They don't exactly solve different problems. Look at Java and C# and Python web servers. They have very same feel. You expect same thing. You expect the class and the callback function, etc. So it just looks slightly different from user point of view. Now the underlying technology, there are differences here and there, and they try to solve different things, but to the end user they're the same. developing one language to solve a problem of another language, but then creating a problem that the other language was designed to solve. That happens a lot. Like, hey, we want to allow you to create your own operator. Well, C++, you can override operators. Well, we don't like C++ because you can override the operators. What? So it gets kind of confusing sometimes. They, and I put quotations, they claim, because I'm not one of them, whoever they are, they claim that languages are tools. Each is good for a task. Well, that slightly is true, but in general, it's wrong. While it is true that a subclass of languages is good for a certain problem, there are many languages that fall under the same subclass. For example, C# and Java, they are very much similar from programming paradigm. Now, if you tell me that the inner workings of the language solves different problems like add security or something, well, I can say you can use same syntax as much as you can and then extend the implementation. Why do you have to create slightly different syntax for that language? Yes, languages have differences, and each difference is to make up for the shortcoming of another languages and the shortcoming of humans. The language is not secure or not secure. People make the language secure or not secure. People write wrong code. They point to invalid memory, and that's just the human nature. And that happens all the time now. Yes, Java is safer to the developer, but how many times you get Java updates on your machine to solve security issues? I mean, come on. They say that the application itself, you as developer, won't make mistakes and you cannot be hacked when the language itself has vulnerabilities. I'm not saying Java is bad. What I'm trying to say is the fact that they say one language is more secure than another. Well, one language is more secure from you, the developer, from other, not the language itself or the program itself is more secure. So the point here is the problem, the burden shifts from one person to another. Now, yes, we are in the business of making money, but I will tell you a story shortly. Now, my subjective point of view, and I emphasize on subjective, and you can start a war in the comments. I think you should master, and I mean truly master, 3 languages, or 3 subclasses of languages. One is low-level language. I choose C over C++ to master. I mean, I know C++, I've coded a lot in C++, I'm very fluent with it, but I would be just fooling myself if I claim that I'm a master of the language, because the language has so many features. I can be a master of a subset of that language, C++. But you may be just fooling yourself to think that you're a master of C++ if you haven't coded in that language for 5 years or 10 years in a row. And now C++ 11 and 17 is coming up, and your mastery will go down, and you have to relearn that unless you're one of those super high intelligent people who are writing the languages and its new features. You won't be the master when the language comes out, at least 2017 spec. Now, by mastering the language, you are the king when you know low-level language. And I mean you are the true king of your machine. It is like top chefs making all the ingredients for themselves. They have their signature dishes. Now, yes, one chef may not have or the time to cook 1,000 signature dishes. They end up buying half-made solutions. No matter who they are, you cannot possibly make every single dish in the world from basic ingredients. But to be a master chef, you must be able to make new things yourself. And to do that, you need that mastery of the ingredients. You need to understand your platform. Yes, it's a slow process. It slows you down, but that's for a good reason. You will understand the platform, which makes you a better programmer and makes you better in other languages, no matter what. An average Joe may open Java, for example, use TCP communication, throws it on the network, and uses Java on the other end, and life is great. But then he switches Java to C or C++, and based on the byte ordering, not following the standards of big endian on the network, you can easily have that person run into problems, and now something looks wrong and you cannot receive the data properly. Why? Because you do not understand to begin with what byte order is when you throw it on the network. Yes, it slows you down, but you become a master of the trade. So mastering a low-level language is really important. Now, you don't have to master the solution to every problem in the world, but you need to master what the language can do for you, to be aware of all, at least from low-level point of view. You'll be aware of challenges, the modern challenges in computer design. What does it mean to be 32 bits, 64 bits, memory alignment, all that stuff. And when you know it, other stuff start making sense to you. One of the funny things is when I started to do OpenGL in Java, that felt home to me. Like, oh yeah, I know what's going on there. It seems so natural because I know C. And a Java programmer may look at that and they'll be thinking, like, what's going on? Why is there a hidden state somewhere? What the hell is going on? Not to say Java guys are not good. Every language is just like musical instruments. The human nature is the limiting factor. The human is the limiting factor. If you're great in piano, if piano is easy to play, you can do more with it. Same thing in Java. You can do much more in Java because the burden has shifted on the Java virtual machine developers to provide all the features to the Java developer. But then the Java developer is expected to build bigger application. But anyway, low level, that's a must. Do yourself a favor. Learn a low level language. Even if it's assembly, you like assembly. For whatever reason, try that. Now the second language, functional and preferably embeddable functional language like Guile, Scheme. There is a lot to say about functional languages, and this whole thing can take on a different discussion and what makes functional languages powerful. I can simply put it this way. When you have a compiler, you're writing code in a syntax, which is C syntax, C++, Java, you name it. And then you have the compiler that runs through your code. It checks the syntax. Then it's the lexical analysis. Then it creates an abstract syntax tree. If you're not familiar with what abstract syntax tree, Google that. You will learn something today other than my subjective point of view. That will make you a better programmer. This does not necessarily, or most likely it will not add value to your programming career. So with the abstract syntax tree, the structure of the code is known to the compiler and it can spit out machine code. In functional languages, you are literally coding in a style that's very close to the abstract syntax tree, which means when you run your functional code program, it can read itself and be aware of its inner structure. So you can load a program in memory which can easily modify itself. It's very malleable system. It's data, they call it data and code are the same. I like to call it as the code is aware of itself. It's aware of its own inner structure. So that can take on a whole different discussion, a whole video. I won't go any further on that, but that's why you need a functional embeddable language. And why embeddable? Because you can call that simple function from your C program, and then you get to higher level constructs and libraries. So you can focus on your C for what you need and functional language for expressiveness. And then master a quick, dirty language, rich in libraries. So the third one is to focus on the richness in libraries. And I personally choose Python. It's good for quick hacks, applications, application layers, like you can simply just go the web browser, which start calling on your C functions, and see your C functions can execute functional scripts, and you can have this very nice, well-integrated system. Now, yes, you can simply choose Java for all the things, but then you run into problem. Do you want the performance? Well, yeah. Do you want the richness in libraries? Well, this way, Python, you do what you need quickly because you don't want to solve the same problem twice. So you do that in a language. If you don't have libraries for it in C, you do that in a language that you know, like Python, for example. And you call your embedded function, and then you can put business logic, for example, in functional languages. So why do I choose C over C++? Unless you are after generic programming with templates, or metaprogramming they call it sometimes, I find C++ meaningless, honestly. Now, don't get me wrong, generic programming is powerful, but unless you're after that specifically, you can get away without C++. That generic programming is a thing, though. I mean, seriously, you need to look into it if you don't know much about it. I'm not a master or anyway near becoming a master in generic programming. I'm still learning that. It takes a slightly different mentality to approach it. Generic programming is more or less you're programming the compiler and what kind of code it has to spit out. Now, why do I choose C? You can do data abstractions in C. Look at Linux interface or Unix-based systems interfaces. It's all done in C. They have very nice abstraction system, and it works. You can have very nice frameworks written in C, like GTK+. When I looked into that, it does use macros, but the language is so natural and it feels like any higher level construct. In C, you have to understand how the operating system works and how resources work, unless of course you use Windows, and there's a short story coming up on that. In C++, you still need a bit of that, but in addition, you need to understand how the compiler works. That's very important. You can do a lot with the language, but you must do them in groups, like there is rule of 3, rule of 5, when you override this, you override that, etc. So it's dangerous. So you really have to understand how the compiler works, or what you do is dangerous. References in C++ are a really nice thing, and that's the only thing that I wish C had. References. I cannot say more about how much I really like references as a feature, other than generic programming, of course. But generic programming is a whole new dimension. Remember when I talked about languages are not orthogonal? Generic programming is a feature that's orthogonal to other languages. Well, you can have macros in C, but metaprogramming is really different, and it's at compiler level. Object-oriented programming is overrated, honestly. That's how I feel. You prefer data encapsulation, and that's what they always teach us over inheritance. Then you see you can do that. You can encapsulate structure with a structure. You can use static functions in a header file to hide the functions from the outside world and expose other functions, which become like methods on your structure that you pass. And if you want static variables, that becomes like a global variable in a static global variable, which is hidden in the header file. So you can do tricks. But why don't people do it? Because if you need to do these, then you move on to C++. But you can do it. To some extent, it makes sense, data encapsulation. It does make sense in certain aspects. There's big argument about data encapsulation, and people understand Linus Torvalds. They misunderstand him. He doesn't like data encapsulation. He doesn't like it in the Linux kernel, because the Linux kernel is monolithic and it all comes out as one binary. Data encapsulation is not necessarily a good thing there. You need data encapsulation when you're providing libraries or functions like the pthread library, etc. When you expose something to other people, then data encapsulation makes sense. It doesn't always make sense unless you're protecting yourself from yourself, but that means you have lack of discipline in programming. So the story of C, my subjective theory of why C is a bit behind or appears to be a bit behind, although it's not. There were languages called A and B, then there was C. That was in the 70s, 1972, according to Wikipedia. C saw the light. Unix was rewritten in C, and if you think C sucks, basically that's the proof that it works. Agile back then was not a thing. Agile as we know it today, not agile in its true sense. Now I have few reservations against agile processes. I do believe in agile and I only work in agile process, but it's in its raw spirit of agile. The whole idea of agile is to be agile to solve a given problem and adapt your thinking and methods to solve that problem. Defining agile in itself as a strict process is just plain stupid. It's really plain stupid. When they tell you, I've seen that over and over, that people are on a time release for 2 weeks and they have to show something. Why? Because it's agile process. Well, that's not agile. That's just another fast cycle design. Agile means, in my opinion, you have a problem, you look at the problem, you partition it to smaller problems, and you go at each one separately, doing what you need to do to solve the problem. Simple like that. That's the definition of agility. Anyway, then come other high-level languages like Common Lisp, which actually the Common Lisp languages, they started in the 1950s actually, and there were actually Lisp machines. But Common Lisp became a standard, I believe, later than 1972. I have to check on that. It proved to be good actually, and I really like Common Lisp, and it's my functional languages of choice. Emacs lives, can I say more? Then other languages appeared a lot in the 90s. C++ though came in the 1983. But there's C99 spec, which actually covers for lots of the shortcomings of the C language. Python came in 1991, Java in 1995. So there are other languages that came up, but we're gonna focus on these for now. These were nice and easier to use, and thus they were more productive, which is good. You want productivity. However, the core of these languages was written in C, or maybe C++, but basically in a low level. But mostly if there's interfaces, the ABI, application binary interface, it's usually written in C unless you extern C on your C++, etc. That's a different discussion. By then, computers became popular, and it was easy for youngsters to learn languages. That's how I personally started in 1997, or that was 1996, somewhere there. I was 14 years old, and I learned programming from the basic help menu on MS-DOS. I had no internet connection. I just go through the help menu, execute the examples, and I figured out how to program. Now, if I would have ever seen an attempt to explain what void star const star could even mean, I would just quit programming. So C is not for youngsters who have not seen a programming languages before. They need more expressive language, more logical structure where they can exercise logical ideas versus understanding the architecture of the machine. But the thing is, at that time in the 90s, people started having personal machines and they started to learn how to program. And the best language to them became the language that they understood and they became effective in it. Like when I programmed in BASIC, it wasn't structured. You had the goto statement. But every time I call a goto, I would, for example, increment a number, an integer. This way I know that I can return back to where I came from. So I created structure into the language. Again, it's a Turing machine, complete Turing. It's a Turing complete language. That's what I'm trying to say. But I built structure around it. That's why I appreciate structures in C. That's a feature of the language, but you can you can get along with it with some work in other language. Anyway, then the internet happened, and that changed lots of things. With the birth of the internet, people started writing free and open source libraries. Now, of course, C was not going to be used. If you think about it, literally, you need to go to school to understand C if you want to, because you have to understand most likely the operating system behind it and the memory layouts, unless there's someone who can help you to understand it. Or at least that's how it was for us in the 90s. There was no YouTube for us. It wasn't as easy as today. Moreover, people used Windows because Linux was still developing, right? 1991. So when you use Windows, it's very hard to get any information whatsoever on how to create a thread and how to interact with your operating system. So C was just a closed box programming language. While if you look at a Unix-based system, C is not alone. You are not alone. That's from Doctor Who, but C is not alone. C is supposed to integrate with the operating system. It will rely on the system calls, etc. Now, some of these system calls are available in Windows, how to open a file, manage file, but with Linux, there's more. You can create threads. There's a bunch of other things that you can do. It's supposed to work all as one whole system to be a rich language. Anyway, people used Windows, and interfacing with other OS is a nightmare. We did say that. Lack of manual pages. I mean, you could do it for Windows, but the information wasn't easy to get. So most people preferred higher level languages due to availability of frameworks and libraries, not due to the language itself. Why would you use Python? I use it because almost anything I think about is there. I want Bluetooth. Hey, I import the Bluetooth library. Bam, done. So, productivity. That's where embeddable engines become powerful, like Lua scripting engine or Guile. The idea is you optimize in the low-level language, or you interact with the operating system with the low-level language, and you can put business logic in a higher-level construct. I personally prefer Guile, and I think the Free Software Foundation made the right decision on choosing Scheme or Guile, which is the GNU version of Scheme, as extension language instead of Lua. It's really hard to appreciate what functional languages can do for you, and I can tell you a little story about that, why I really like functional languages after this video. Now, an exception is C++. There are very nice frameworks out there like Qt and Unreal Engine 4, for example. If you actually try to code under these frameworks, C++ doesn't feel like a burden. You don't have to understand the inner workings of the compiler because people got paid to do that. They are the masters, basically, of the languages. They build reflection in the system. Can you believe that? Now, in that case, C++ feels more like C# to some extent, while maintaining its performance. Now, that does not contradict my point. That actually supports my point, because are all languages needed? If we can create all these libraries, and the fact is we choose a library or we choose a language most of the time because of the libraries it provides, not because of the language construct itself. Now, since this is the end of the video, I'll tell you why I like functional languages like Guile. I was writing a neural network program. It's actually on GitHub somewhere. Anyway, the reason why I was doing it is not to have yet another neural network implementation. It's to exercise my C++ programming skills, so I decided to pick up on that. Now, when I was doing that, I had very nice system, but I wanted to play with neural networks, and I realized that right now, if you look at TensorFlow or other languages, you have to open a scripting language and script your way through it. So I wanted to create a way where I can manipulate the network live. So I ended up creating functions in my C++, and I wrote a small reading command, a read line command, where I can simply type a command. For example, I can write something like create network with 5 nodes, etc. And the string gets passed to the program, and the program parses through that code and calls on the embedded function. So this actually worked, and I was able to manipulate my neural net. I can create them on the fly, train them on the fly, modify them on the fly, etc. But in order to do that, I put some thought to it, and I thought, before I even knew about Lisp and functional languages, I used to not like their syntax. The natural way to me came in the form of Excel macros. If you think of Excel, if you want to do addition, you say add x comma y, which adds x and y. If you want to add a multiply, you say add, inside the add you put multiply, etc. It's just a macro style. It turns out if you try to parse something like that, it's very easy. It's really easy. You're just building a tree. But it turns out that that's the abstract syntax tree of your language, and you have the command structure in memory. So then I thought, well, if I can do that, then I can save a bunch of commands in a text file. So I did that. I saved a bunch of commands in a text file. Now I can load that file and execute the commands, and I realize I have an interpreted language. And it was so easy to do. The line of code, it was literally like 500 lines of code to do that. So I went to talk to with one of my friends, and I told him what I've done. He's like, oh, that looks like Lisp. So I go and check out Lisp. It is the same. But from that point, I really appreciate the functional languages and how powerful they are, because the network can load itself, my neural network can load itself, and it executes the code, and based on the result, it goes and modifies the code itself and re-executes itself. So in a way, the network programs itself. Now, if you ever think about a program that can write programs, functional language is a natural way to go. Anyway, if I, someone who's not so smarter than any of the programmers out there, just average Joe programmer, look at a problem and I find that functional language is a natural choice, that tells a lot about natural languages. Sorry, not natural, functional languages. Anyway, I hope you liked this video about my choice of language and my extreme subjectivity. I don't know if you agree or disagree, and my goal is to start a language war. That actually is my goal. Let's see what you have to say. Thank you for watching.